Problem number 6. Again, you have just this one triangle, so we're not going to use congruence. What we want to do here is somehow show that this is an isosceles triangle. Okay, so in order to do that, we need to demonstrate that AC and BC are equal to each other. Okay, so that's kind of the process of working backwards from the end state. So now we need to figure out what different ways do we have to show two sides are equal. So we can either do it by corresponding parts of congruent triangles, which we don't have multiple triangles here, or we can do it by showing that the angles opposite those sides are equal. Okay, and so that's probably the route that we're going to take. Okay, so the first thing is let's make sure we introduce the two angles that are opposite these sides, AC and BC. Well, angle 3 is already introduced, but it's not introduced in an equation form, so let's interpret this into an equation form. If 3 is a supplement to angle 1, what does that mean the sum of those angles has to equal? 180. Okay, and the reason for that is definition of supplement. You have to include this as a step. You can't just make the interpretation. Even though that's true, even though you can tell from this that angles 1 and 3 add up to 180, you have to specifically state it in a formal proof. Okay, so angle 3 has been introduced already. We still need to introduce angle 2. The only way to introduce angle 2 is the fact that angles 1 and 2 are a linear pair. So we can introduce that in the equation form. A linear pair add up to 180 by definition of linear pair. Okay, so now we've introduced our two elements, 2 and 3. They both happen to be parts of expressions that are equal to the same thing, and if two things are equal to the same thing, they're equal to each other. So we can say that angles 3 and 1 have to equal angle 1 and 2. And the justification is transitive property or substitution. And now we can remove the exact same values from both sides of these equations, and we're left with the relationship that we were looking for, which is angle 3 and angle 2 are equal. And that was subtraction property. And once we have those two angles are equal, then we know that the sides opposite them must also be equal. So we can make the statement that AC is equal to BC. And the justification would be in a triangle, sides opposite equal angles are equal. Okay, so again, you could also state here that base angles of an isosceles triangle are equal, and that would work for both of them. Usually I'll write it in a more descriptive term. Okay, so once you have that these sides are equal, we now know that the triangle is isosceles, so we can finally realize our end state. And when you write your end state, just write it in exactly the same form that it asks you to. And the justification is definition of isosceles triangle. Okay, isosceles triangle is defined as a triangle with two equal sides. Therefore, we had to prove that those sides were equal.